In the last tutorial we went over variables, if and else statements, and some parsing of integers from strings. This tutorial we're going to go through while loops, adding some detailed comments and some complex logic. So it seems like a short list, but this video will probably be around an hour long. So what we're going to do is create a program that is going to have the user guess a number between 0 and 100, and in the shortest possible amount of guesses our program is going to determine the exact number that that user guessed. So we need to start with console.writeLine, which you should be familiar with now. We're going to just ask the user to think of a number between 0 and 100. And then we're going to wait for them to press enter. And one thing we're going to start doing is adding comments to almost every line of code. So it's a good practice to get into at the start before you start going further into programming and it doesn't become a habit. So you want the habit to be comment almost every single line of code that you do, even if it's really obvious. Because glancing through code with written, human-readable comments is a lot quicker than trying to decipher code, even if the code's obvious. So from years of experience, trust me, you want to see a comment in almost every line, and it'll really help you going forward in the future, as well as when you come back to look at your own code. So we're going to add a comment to this, which is just ask user. Or rather not ask, we haven't, well, yeah, that'll do. Ask user to think of a number between 0 and 100. So after the user presses enter, before we get going in terms of the logic, which will be a while loop, which will effectively loop through and try to guess the number, we need to create a few variables. So we've asked the user here to think of a number between 1 and 100. So we need to define that number in code. So define maximum number the user can guess. And then we want to keep track of the number of guesses, because part of the way that we're going to calculate this number is through effectively halving all possibilities, divide by 2. So the maximum number of guesses we should need to guess any number of any size is 8. So if we halve this number and halve again and halve again and halve again, we'll guess between 0 and 100 within 8 guesses at the most. So we just want to keep track of that as a general interest. So can't type today. Keep track of the number of guesses. And then we need a range, because we're going to say, if we want to guess a number between 0 and 100, the first question we're going to ask, is it between 0 and half of 100? So is it between 0 and 50? If the answer yes, we know it's between 0 and 50, so we're going to repeat that loop. And we're going to halve 50 to 25, so we're going to ask, is it between 0 and 25? If the answer no to any question, so say the answer no to between 0 and 100, then we want to guess, if the answer no between 0 and 50, we know it's not 0 up to 50, so it's got to be 51 to 100, so we go the opposite way. So we're going to have two variables, which is effectively the start of the range and the end of the range. That we're trying to guess. So we need 2 more integers for that. So we'll call them guess2, and that will start at the lowest number of 0. And then we want the guess. Wrong way around. Guess from. Now we want the guess2. which will start off at half of the max. As we discussed, we're going to initially start by guessing between 0 and 50. So that's just max divided by 2. So you should be following along so far. This is all stuff you've done before. Console, read and write, defining some integers. And now we're going to do what's called a while loop, because this is a recursive behavior. There's no set pattern of if this, else that, if this, else that, and infinitely going down and having a huge group of ifs that say if it's between 0 and 50, no, else if it's between 51 and 100, no, if it's between 51 and 75, and you imagine how long that would go on. You'd have a huge list of ifs. So what we're going to do is a while statement. So a while statement works similar to an if. It's a while, and then it's an open and close parentheses, similar to an if. So if you think of if as like that, you've got if and then some logic of true or false here. So a while is the same. It's while, and then it's a true or false here. And what it means is while the statement inside here is true, it will run the code from here all the way down to here. Then it will recheck this logic, so it will do another check on the variables or whatever you've put in here. If it's still true, it will run again and again and again, and it will go around in this constant loop until this logic is false, or inside this loop we tell it to break, which means escape this loop and carry on to here, outside of the loop. So we need to continue in this while loop until we've found the number. And because we're going to start by halving the number, we're going to go the lower side of the range every time. So the lower half between 0 and 50, if they say yes, between 0 and 25, we're always going to be the lower side. We're going to say while the guess from, which is the lowest possible number, while the guess from, and this means isn't equal to. So double equals means, say, while guess from equals 50, this would run. So a double equals is a Boolean logic. So a single equals sets the thing on the left to the value on the right. A double equals is a check. So it's actually saying, is guess from equal to 50? So the double is a logical check. So equals would mean it is equals. The exclamation equals means it's not equals. So it's anything except this value. So if we said guess from isn't equal to 50, this loop would run if guess from was 1, 2, 100, 7, minus 5. But once it hits 50, then the logic would return false because it is equal to 50. So we're saying when it isn't. So what we want to do is continue to loop while the guess from the lowest value isn't equal to the maximum. Now the maximum right now is 100 because we're unaware of any truth so far. The user hasn't answered any question, so the value could be between 0 and 100. As soon as the user answers the first question, say is it between 0 and 50, and they answer say yes, we now know the maximum number possible is 50 because they've told us it's between 0 and 50. So we'll then set this maximum to keep track of the known maximum. And effectively, if you keep halving that, so the user answers yes to every question. Is it between 0 and 50? Yes. Maximum's now 50. Is it between 0 and 25? Yes. Maximum's 25. You'll get to the point where the max is between, the guess from would still be 0, the max would end up being 1. And then you know the fact that you're 1 off inside this loop, we will then ask the question, is it the group from or is it the max? Because there's only 2 possible values left. So you'll see how this works out as we go. But for now, think of it as while this value, which is currently 0, isn't equal to the max, which is currently 100. And this will continue to loop. So it'll make more sense as we go. So we want to put a note here, a comment. So while the guess isn't the same as the known maximum value. And now inside this loop, we're going to ask a question. So we're going to guess a number. So to start with, we need to keep track of the guesses. So we're going to say increase guess amount. And you can do guesses, and then again, if you remember the shorthand, when you were doing things like, say, guesses equals guesses plus 1. Now the shorthand to that would be, because the left and right are the same, you just get rid of the right hand side, get rid of the operator, and put that before the equals. So it reads guesses plus equals 1, which means add this number to that number. So add 1 to guesses. So guesses plus equals 1. Now you can shorten this even further. When the value is a single increase or a single decrease, you can remove the equals 1 and simply put 2 pluses. And you typically write that by then putting the plus next to the variable name. So guesses plus plus simply means add 1 to guesses. So just increase it by 1. Similarly, guesses minus minus decreases it by 1. So this is a shorthand version of increase guess amount, and then we'll just put in brackets in the comment by 1 until you're familiar with this statement. So the program's going to start. It's going to ask the user to think of a number between 0 and 100. We've set up all the variables ready to go. We've got this infinite loop until guesses from while guesses from isn't equal to the maximum. And then each time we run this loop, we're going to increase the number of times we've had a guess. So now it's time to actually have a guess. So we want to console.writeLine, and remember the $sign before the double quotes means that inside of a string that we're typing, we can use curly brackets, and then we can place variable names directly inside the string so it reads easier. So we're going to say, is your number between something and something? Now, as we mentioned, these are the two variables, between, from, and to. And right now it's between 0 and 50. So this will read out, is your number between guess from and guess to. And let's just go ahead and run this to see. You get a feel. It'll never end, but you'll get a feel for what's going to be output. So if you press start, or you click start or press F5, and you see, I want you to think of a number between 0 and 100. Okay, so you press enter. And you see this infinite loop that's scrolling really fast. So let's just pause that. And you can see it's going to ask, is your number between 0 and 50, 0 and 50. Now, that just ran infinitely because there was no console.readLine to wait. We haven't finished the logic, but you get the idea. This is now starting to form this loop. This while loop just ran continually over and over because this condition was never met. So it continues to run and continues to repeat. So we need a comment on what we've done here. So ask the user if their number is between the guess range. And now we need to read the response. We need to know what the user's thinking. We did this in the last tutorial. So you can do string response equals console.readLine. So now the response will be whatever the user's typed, and then press the enter. Now we need to check to see effectively if the user's typed yes or pressed yes or anything else. We're going to presume if they don't type yes or Y that they mean no. So that will account for any other statement. We're simply going to presume if the string they've typed starts with the letter Y, then they want to say yes. So for this program, that's fine. It's a simple enough presumption. So we need an if statement, open and close parentheses, and then curly brackets. Now the statement is, you want to take the response, which is a string, and we just want the first character. Now, because the user could type capital Y, they could type a capital Y, they could type a lower y, they could type yes, they could type yes with a capital Y. All these things are different in terms of variables. They're all different strings. What is similar is the start character for the word yes is either a lowercase or an uppercase. So we could check, we could say if response, and then you can use angle brackets to access a specific point in that string. So 0 would be the first letter, 1 would be the second, 2 would be the third. This is an array accessor. So as we mentioned before, a string is actually a class, and it's an array, as in multiple items. It's a list of single characters. So this is an array accessor. So by doing it square brackets, we're saying we want the first character, and you can see it's returning a character here. So if we did response 0, and then a double equals, because we want to check, we're not trying to set this value, we're actually asking what the value is. Single quotes, because that's for a single character, whereas double quotes are for a string. A single quote is for a single character. So we could say if response, the first character in what the user typed, if it's a lowercase y, and then you can do your double pipe, which is for or. So if the response is a lowercase y, starts with a lowercase y, or the response starts with an uppercase y. And this would check if the user, so we want to say, if the user confirmed their number is within the current range. So you can do this is fine. This has got a few problems though, and I'll show you what those are. So firstly, we're under the presumption that this string actually contains information. So what I mean by that is, let's put a breakpoint here, and let's run. Is your number between 0 and 50? Now I'm just going to press enter. I'm not even going to type anything. And now you can see this response. It's just 2 double quotes and the string inside, and there is nothing inside the string. So effectively this is an empty string. So we're now going to try and access the first character in that string. Well, that doesn't exist. So as we step over, you can see now we've crashed the application. Index out of range exception. So what that means is your application is now just going to crash. So that's not good. That's something you want to avoid all the time. So firstly, we should check whether the response is null or not before we even check if it's Y. So you could do that by doing, this gets slightly more complicated. So now we're going to say, well, let's keep it a bit simpler and let's just do an if inside of an if, just so you can see it nicer. So first you could say if response isn't equal to null. So this means we've actually got a response, which should always be false in this case, because console.readline will never return until the user presses enter. So you're always going to get a string, but it's going to be an empty string, but it'll still be a string, it won't be null. And by null it means completely unassigned. So this is a check you tend to do before you try to access an object. It's good practice again, because the string could be null. In this case I know it never will be, but you have to be under the presumption that you don't know whether that string has been set or not. So the first check is if the response isn't equal to null. And then you want to do double AND, which means, and as well as that, we want to make sure the response has some characters. So on a string you can do dot length, and that gives you the size, the number of characters inside of the string. So you can say and the response length, and then the greater symbol is greater than 0. So what this check does is say, before we check and try to read the first character of the response, we want to make sure we do have a response and that we have at least one character in because it's greater than 0. And then you wrap this inside the curly brackets of that if. So first you check this, then you're safe to presume this. Now what you'll start noticing here is it's okay if we want to check if it is within the range, if it's yes, but now what if it isn't? So we've now got an else here for if it isn't a yes, But now we also have to deal with this else, which would be over here. And yet both of these else's should result in the same response. If it's not, we want to do the same piece of code. So we've instantly got two places that we now will have repeating code. So you can get around that in one way by combining these two if statements. And to do that, you simply take the if statement. Let's get rid of that. Tab that back in. And you can say if, and then inside of the brackets, this is where it gets a little awkward to see. You have to keep track of how many parentheses you have. So see this self-contained, you click on this, it highlights in grey the start and finish. So if you go to this part, you can see there's the finish. So it's going to evaluate this statement first. So it's going to say if response isn't equal to null and response length is greater than 0, if that's false, it's not going to carry on, it's going to jump to this else. And it won't even attempt to do this part. So the way if statements work, you can presume if this part, which is checking if we can do the second part, returns false, it won't go ahead and try this. So you're safe to do things like if the response isn't equal to null, and then inside the same if statement try to do something else. So we're going to say if the response isn't null and it's greater than 0, and that's got to be within this parentheses because this is an AND statement. You want it to be not null, but also have at least one character. So that's a check in itself, as we saw. So that's one part of the check. So there's part of the if, and then you want to say if it's not equal to null and the length is greater than 0, and now and the response is y, or the response is capital Y. So because this is now an OR, you don't want the statement to read if the response isn't null and it's greater than 0 and the response is y as one statement, or, and then it's just going to run this independently if that fails. It's going to then try and access response. So because you've got an or, you need to put parentheses around the two logical statements. And as you can see, this is starting to look fairly complicated and awkward to understand. So when you come back to this, you're going to look at this, and it's going to take you a good few minutes to try and figure out what's going on. So you can simplify this by removing this logic. So this is effectively checking that we have a response. So what you can do is you can cut that information, so Control X, or right click and cut, and you could make a variable. You could call it Boolean has response, and then you can set it to that logic. So now it's broken down. We've got a check that clearly says has response, and it's saying the response isn't null and we've got some information. So then you could put in if has response and the response first character is a lowercase y or an uppercase y, and that becomes a lot more readable and understandable. And then you could do your logic. So that's a perfectly valid way of doing this loop. We could say get the response from the user. If we have a response and the first letter was y or uppercase Y, then do this, else do that. So let's leave that in for now. Let's just copy and paste this read line. And let's just say you answered yes. And here, if they didn't, you answered no. And let's run that and see what we get. So F5, or click the start. Press enter. So is your number between 0 and 50? So let's answer yeah. And it correctly says you answered yes. And then it's just going to loop again. Did you answer? Let's put no. You answered no. Capital Y is a yes. Now you could do a space and a Y, and that will say no because the first character was a space, not a Y. You could also say go. You could type something completely irrelevant, and it will also say no, because we are only checking if the first thing we type is lowercase or uppercase y. So for the most part that will work with yes, yeah, yes, which is the expected response from the user. So this is all good and, like I say, usable, but there is a lot nicer way of doing this statement. C#'s got a lot of powerful features, especially C#6. So what we're going to do is we're going to tidy up this response. But this is good to know because this is how you would do it in other languages that don't have the ability of C#. So if you drop down to lower languages, or in general you just want to know, you need to know this type of way of doing logic and checking for nulls and checking lengths and things like that before you do the advanced way, because you need to have the foundations. So this is good to know, and this you should take a screenshot of and be aware of what the logic's doing, so all the checks that we're going through. So I'm just going to comment these two lines out so you can see, and I'm going to tell you what part of each of these lines the new way replaces. So instead of doing this has response, which means we've got to check whether this is null. So instead of having to check whether it's null before you access and do anything such as dot length or try to get a character, you can simply type the name and you put a question mark. And now this is a safe thing in C# that means the question mark right after a variable name before you access it with a dot to do anything with it. So this is like saying response dot length. So we could do a response question mark dot length, say is greater than 0. So now this check, by just putting a question mark between the response and the access of the information inside of it, completely gets rid of this statement. So there's no need for now response isn't equal to null and response is greater than that. So this would then become if response question mark length is greater than 0. And that's your has response. Now, there's also no need to check the length is greater than 0, because instead of using this array accessor, we're going to use something that's called link, L-I-N-Q, and we won't go too much in detail right now, but we'll just show you a really basic usage of that. And what we can do with link is mainly query arrays, but you can do a lot more than just arrays. And remember, a string is an array of characters. So it's good for doing things like for eaches and getting the first element, the last element, ordering by, sorting by. A lot of things that, again, we'll get into in later tutorials. But right now, we're interested in the first character of this string, which is an array of characters. So we're going to use link. So we keep the question mark in to make sure it's not null. But we don't need the length check now. And we can just say response dot first. And this is link. And if you're wondering where it comes from, we just type this first. If you click on the name first and you press F12 on your keyboard, or if you don't use keyboard, you can right click and go to definition. And this will then search and find and open this file. And you can see it's system.core up here. And if you scroll up, you can see it's inside the system.link namespace. So this is the link I'm talking about. So again, we won't go into detail about that right now, but just bear in mind this is a link statement. And the reason we can use it is because up here in the using statements, Visual Studio already added the using statement for us. So by doing response question mark dot first, this first will do this part in terms of response 0. Now the problem is we haven't done this check yet. The length is greater than 0, but I mentioned that's not required. And the reason for that is, as well as first, you have an overridden function, well, more of a different function, and it's called first or default. And this says returns the first element of a sequence, or a default element if the sequence contains no element. So what this means in terms of our string is it will return the first element. Well, our element is a character, as it says here. So it will return the first character of a string, or a default value, which in this case would be a null character, but at least it wouldn't crash. We'd actually get a null response back. or a default character if the sequence contains no elements. So effectively if the string contains no characters. So that's great. So that means we can just call first or default. And now response question mark, which replaces response isn't equal to null. And then first or default is a combination of checking if the length is greater than 0, return the first element. So in this one nice simple statement, we've effectively got either the first character or a null value. So now we can do a check on if that equals y, and that would equal the lowercase. And then to check the uppercase, we could do or it equals the the lowercase and the uppercase. Now we can take this one step further because you'll soon find out the more videos you watch. I'm a real fan of one-liners and getting everything in a single piece of logic as clean as possible. So that we've got two checks right now, and it's an uppercase and a lowercase check. So instead of checking whether they typed a lowercase or an uppercase, we'll go one step further. We'll get rid of this uppercase. So in order to get the check to be on a single lowercase, what we want to do is convert this whole string into lowercase first. So you simply do a response question mark dot to lower, and this returns a copy of this string converted to lowercase. So if we do that before we then get the first character, we now have make sure we get a response. If we have a response, we cast every character to its lowercase version. So a capital A will be a lowercase a capital Y, a lowercase y. And then we get the first character, or if there isn't one, we just return nothing. And then we simply check now if that's a lowercase y, which is the only response we could have from typing an uppercase or a lowercase, because this converts it down to lowercase. So this whole logic has gone from all this messy, really hard to see data into this statement that's almost human readable. So if the response to lowercase, the first letter is equal to y. So it's much nicer to read. So this accomplishes the same thing as all of this. And if you get used to writing things like this, making use of the extension methods and the link queries, it becomes a lot nicer to use, a lot easier to read. So let's delete that. If the user confirmed their number was within the current range. So now let's double check that this new code works firstly, which is always good to prove that your code works. So F5 to run, press enter. Is your number between 0 and 50? Y, you answered yes. Capital Y, you answered yes. Good. Press just enter. You answered no. So it's good. We've got a good test there that we're happy that if we type Y or yes or any combination like that we're going to get the correct logic. So now we can happily move on. So we've now asked the user whether their number is between 0 and 50. So what happens if they've answered yes? So as mentioned before, if the user's answered yes, we know the number is between guess from and guess to. And that now means that our maximum number, which is the thing we're trying to get to equal the real number, the one they've guessed, originally it was 100. While the user's just confirmed that the maximum, their number is between 0 and 50. So it's between guess from and guess to. So we now know the maximum number is at most the guess to value because the user's confirmed that. So we say, set the new maximum number. And that maximum number is the max variable. And that wants to now equal the guess from. So now the maximum is going to be 50 in this instance. And then once they've answered yes, we need to now ask the next question, because this is going to go around in a loop. So it would be no good now if we just answered yes, set the new maximum to that, and then in the next cycle it comes in and it asks, is it from 0 to 50? We need to change this guess to, because we now know that it's between 0 and 50. And what we're going to do is effectively go back to the start and do what we did at the beginning, which was to ask for half of the maximum value. So the max has changed, so we just need to redo the maximum. And now what you've got to remember is, say they answered no to the first question. It's not between 0 and 50. And we change it to say, okay, is it between 51 and 100? And they answer no. They answer yes. You're going to then come into this loop, and your guess to is going to be 100, but your guess from isn't going to be 0. It's going to be 51. So if you want to then ask for a number halfway between the 51 and the 100, it's not going to be the maximum number divided by 2, because that would be 50. You've got to get the difference between your current range. So let me explain. So the first value we've asked for is between 0 and 50. And that was because it was between 0 and 100. And we did max divided by 2, which was just 100 divided by 2, which gives us 50. So we've now got a max of 50. If we then go, well, let's make it easier. Say we have a guess from of 51 and a guess to of 100, and that's where we were starting. So we want to ask, what's the difference between these two numbers firstly? And then we want to take half of that, so around 75, and we want to ask, is it between 51 and 75? So that's what we're after. You want the new value to be halfway between the known range between the min and the max all the time. So you're going to halve the number and ask for the lower half all the time. So what that results in is your guess from, and you want to take away, because right now they've confirmed that it's between the guess to and from. So now the guess from has become the new maximum, and you want to now guess halfway between the max and the min. So you're going to minus. So let's just write it longhand first so it's easy to understand. The guess from equals the guess from minus, so right now this would be, say, 50. And you want to get the difference between the from and the to. So guess from minus guess to. So if guess to is 0, then it's 50 minus 0, it's still 50. And then you divide that by 2, and that would be, so this statement here would be 25, which is correct. Now, say we were at 51 to 100, you'd do 100 minus 51 would be 49 divided by 2. You'd be about halfway between the guess to and the guess from. So this part's key. You're effectively getting the difference as opposed presuming that your start point is always 0. So you guess to and you guess from. So you're guessing from, in fact that's the wrong way around. Sorry, that's guess to minus guess from. So your guess to is your higher number. You're going from your higher, from your lower to your higher. So the higher number minus the lower number gives us the difference. And then we get half of that. And then that's what we take away from the maximum. So if that's 0, that's 50. You divide by 2, it's 25. You take it away from the 50, you're down to 25. So what you've done is you've guessed from 0 to 50 first. That's failed. You guess 0 to 25. That fails. You'll come in again. And then you'll have 0 here still, 25 here. 25 divided by 2 is going to round, I believe it will round up because it's 0.5. So you'll end up with 0 to 13. And then you'd have 13 divided by 2, which would go to 7, and so on. So this loop alone should do this response, which we can test. So if we run this code right now, here's your number between 0 and 50. Now remember, we've only got the logic for the yes right now, and we're just testing that we're going to correctly halve the value every time, because that's the point of this program, is to halve the maximum possible range and ask for the lower half each time. So is your number between 0 and 50? We're going to answer yes. And you see something's gone wrong here. So it's saying, is your number between minus 25 and 50? So I can spot what I've done already. I've minus the guess from, and it's the guess to, because it's the higher number we're trying to change. And we've also done that there. So this is why it's good to check every step of the way and to talk through. So the maximum is now the guess to, the higher. And it might be a good thing to rename the guess to guess max and the guess from to guess min, because I believe that'll be easier to spot things like this. The mistake to and from is easy to overlook. So to rename, we have this variable here, guess to. Now instead of having to go, let's say you're going to change that name. Instead of having to say, oh, let's get rid of that, type guess max. And then, oh look, that's gone wrong. We're going to have to find that instance, type guess max. Now you imagine if this variable was in 1,000 places, you'd be going forever. So in order to rename this variable, and effectively rename every instance of that variable, you can simply click somewhere inside of the variable, hold Control and press R twice. And you see this brings up this dialog over here, rename guess to, and everything goes green and it highlights green. And this part's selected. So you now simply start typing on the keyboard your new name. So I'm going to type guess max. And then I'm going to press enter. And before I do that, you can see over here, rename will update 6 references in one file. So the program is the one file, and you can see the 6 instances in green. So that's renamed for us. We're going to do the same for guess from. Control RR, guess min. And there's all our code renamed. And now if we reread what we've written, is your number between guess min and guess max. That's easier to read. Here also we would have spotted this mistake really easily. Max equals guess max. Now if we rename this to min, this would have quite simply said guess min, and it would have been really obvious we've done something wrong. So the maximum number is equal to now the known maximum. And now the new maximum is the current maximum minus the difference, half of the difference between the current range. So let's run that code again. Is it between 0 and 50? Yes. And there we go. So now, is it between 0 and 25? Which is good, because that's what we want. Yes. 0 and 13? Yes. 0 and 7? Yes. So let's see what happens if we keep going. You can see it's halving every time. Is it between 0 and 2? Yes. Now, is it between 0 and 1? Now, when you get to this point, there's no point asking, is it between 0 and 1? Because you know it will be. Because if it's between 0 and 2, the only possible numbers are 0, 1, and 2. So this should really change at this point to say, simply, is your number 0? Let's take a guess, because then if the answer yes, you know the number's 0. If the answer no, you know the number's 1. So let's go ahead and add that part in code. So we're now satisfied this part's good. And this basically says, change the next guess range to be half of the new maximum range, which is what we're doing. So that's all we should have to do for the yes. We'll come to the no afterwards. Let's just get this loop sorted. So here's the while loop. So for every loop of this, which is there to there, you're going to increment the number of guesses. You're going to ask if it's a certain number and get the response. If it's yes, you're going to do this. If it's false, we're going to do something else. And then here would be either way, whether they've answered yes or no, because they could go higher or lower. But in each instance, regardless of whether they answered yes or no, we now want to check if there's only 2 numbers left, so that we can just ask the question. So we want to say, if we only have 2 numbers left, guess one of them. So it's an if statement. So let's make the little statement ready. So now this needs to say if there's 2 numbers left. Well, how do we know if there's 2 numbers left? Well, we know we're guessing from the guess min every time. So we know that this is a guess minimum. and we're guessing from guess min to guess max. So we saw in our application it said, is it between 0 and 1? So that's a clear indication that effectively if guess min is one number less than guess max, that we know there's effectively only one number difference between them, that there's only two numbers left. So you can do that in many ways, but the simplest way to do is to say if guess min plus 1, so add the difference, then equals with a double equals guess max. So now what we're saying is if guess min, which is 0, plus 1, so if 1 is equal to guess max, which is 1, then we know there's only two numbers left. So this is a nice check that basically says if guess min is one number less than guess max. You could also do if guess min equals guess max minus 1. It's whichever you prefer. It's whatever reads nicer for you. I tend to do this way. So if there's two numbers left, we're now going to do another guess, because we know now this is going to be the end. We know we've got the number whatever we do here. So we need to first increment this guess, because we're not going to end up going back to this while and taking another guess here. We're going to do it directly here, and then we're just going to break out of this while because we'll know the answer. So first thing is increase the guess amount again. And then we want to ask the user, let's ask them if it's the minimum. So let's take this bit of code, and we're going to say ask the user if their number is the lower number. So is your number guess min? And you can see here what you've got is it's saying a local or parameter named response cannot be declared in the scope because the name is used in the enclosing local scope. What this means is you've got this name, this variable defined twice, and that's because up here inside of the scope, which is while, so inside of this while scope, we have a string response. So we've already declared the variable, so it exists. So you can't redeclare this variable as a string because it already exists. It's like here, we've done int max, and then we've simply used the word max and set it. We don't need to redeclare it. So you simply remove the string because it already exists. So now you've got, is your number the min? And you get the response. And now you want to do the same check again. So you want to check if the response is yes. So let's take that bit of code. If the user confirmed their number is, and then the new comment will be the lower number. So if the response to lower, first or default is yes. And in this case, what's going to happen is the guess min is the right answer. So, in fact, we've done one other mistake here, sorry. If there's only two numbers left, guess one of them. Now, guess max is half of the available numbers. So, guess max is actually going to be the wrong thing to check here. You want to check the actual max, because the max is the maximum number that it could be. It's not the guessed maximum. We want to know the actual maximum, the highest possible number it could be compared to the current guess. So there's a little correction there. So now, what we're saying is, if guess min plus 1 is equal to the max, and then they tell us that the guess minimum is the answer, we can simply end here, because what we're going to do, once we're outside of this while, because usually this loop will continue until guess min is equal to the max. When we get out of this while loop, just down here, we're going to simply state the fact that their number is guess min, because that's where we're trying to store the value. And here they've confirmed that their number is guess min. So there's effectively nothing left to do. They've confirmed that's the number. We want to escape this loop and just output the fact that the number is guess min. So in order to escape a while loop, so you could do one of two ways. You could actually set the variable max to equal guess min, so that this statement becomes false, because then it is equal. Or you can simply type the word break and a semicolon. And if you double click break, you'll see it'll actually highlight the while as well, to indicate that you're breaking out of the while. So if we do break, we're going to come out of this infinite loop. So what we say is if the current guess plus 1 is actually only one below the maximum possible number, so effectively there's only two numbers left to guess, and they confirm that the number is the minimum number, then we break. So, I'm messing a bracket, there we go. So let's come outside of the while. So you can see here, you scroll up, this is the curly bracket for coming outside of this while. So after the while loop is finished, so effectively just before we close the program, this is now escaped our while loop. We want to output the fact that we now know the number. And in that case, we can say your number is, and then guess min, because that's what we've ascertained. That is the point of our while loop, that we will never get past this until we're assured that the guess minimum is the guess max, is the maximum number. Or we broke because we knew the guess min was the right number. So we're going to come out and we're going to say your number is guess min. So tell the user their number. And then just as a little piece of information, we can say let the user know how many guesses it took. And remember, we were keeping track of the number of guesses we had here. Guesses plus here and guesses plus here. Every time we took a guess, every time we asked this question, we increased this guess. So we can say console.writeLine guessed in the number of guesses and let's just put, say, a couple of stars in front of your number and behind, just as a nice way to indicate it. So this will then output your number is guess min, and we guessed it in this many guesses. And then so it doesn't just close, remember to put the console.readline. So let's go ahead and run it again, and let's check out the progress. And you can see already, if we weren't doing all these comments on every line, look at how complicated this is already starting to look. As you scroll through, it's got a lot of logic. Even though it's a simple program, this is quite complex logic in terms of if you wrote this today and then you come back to it tomorrow or in a week, I can guarantee you won't remember the thought process that went into creating this code, because as you can see, how I've made it is on the fly right now for this video. I'm thinking through as I'm going, and you've seen me make mistakes and you've seen me correct things, and the thought process is happening as you're writing the code. And then you're continually testing the code to prove what you're thinking and what the theory is. So this is only simple, or this is only constructed because you're making it step by step in small chunks and you're understanding it as you're going. You go away, have a drink, have a meal, come back a day later. This is then going to be just foreign to you again. So these comments really come in handy to help you read and understand what you were thinking at the time of writing this code. So you be as detailed as possible in these comments, because it's only ever a good thing. So let's get back to this and let's prove. We're now trying to prove. We know this halving part here that halves the guess. We know that the yes response always halves the guess. We're happy with that. We proved it last time. Now we're trying to prove that after each guess, so while in the while loop, after each yes or no response, we're going to check if the value is effectively only two numbers. So in our case, it's when we get to 0 and 1, where previously it asked, is this number between 0 and 1? This time it should say, instead of doing that, it should actually say, is your number 0? And if it is, we should break, which means we should then hit here. Your number is, and then min guess. So let's test just that part. So is your number between 0 and 50? And we simply answer yes, 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 yes. And now here is the last time it said, is your number between 0 and 1 on the next check? So now our code should hit here and say, is your number 0? So you see we've still got an issue here. So is your number between 0 and 1? Oh no, sorry, that's correct, because right now we don't know, we didn't confirm whether the number was between 0, 1 and 2, because the last known thing was between 0 and 4. So right now at this question before, it could have been 0, 1, 2 or 3. So now at this point we're asking if it's between 0 and 1. And right now, before we confirm that, it could be 0, 1, 2. Yeah, 0, 1 or 2. So there's still 3 possible numbers. But now we've eliminated that, this is going to confirm if there's 2 numbers. So if we answer yes to this, we now know is your number 0. So we know for a fact, because with the previous question we asked was, is it between 0 and 1, meaning it's not 2. So now we're down to 2 here. And then this is correctly identified, we're down to 2. And it's now asking, is your number 0? And because we haven't written the else part to this statement yet, what happens if it isn't 0? We know it's the other number. We haven't done that code yet. So we simply answer yes to this. And we should then hit this break, come out of this loop, and then output that our number is 0 and that we got it right. And there we go. So your number is 0, and it was guessed in 8 guesses. So, and funnily enough, that is the maximum number of guesses. So you'll find that if you're trying to guess a number between 0 and 100, the longest possible responses will be the 2 extremes, like 0 and 100, because you'll continually halve and halve and halve and halve and get down to either up or down to the extremes. Or if you actually go to an upper limit of a mid-half, such as 76 or 77. So there's plenty of math behind why that is. But just out of interest, you should never hit more than 8 guesses. So we're happy that when we hit the fact that we know there's only 2 numbers left, we explicitly ask whether it's one number. So let's just finish this logic off. So if the user confirmed the number is the lower number, which is guess min, then we simply broke. Well, if they answered no, and we know that the maximum is only 1 more than the minimum, we effectively know that the answer is the maximum number. So what we can do here, because we're outputting guess min as the answer, we set guess min to equal the max, because we know. So that means the number must be the higher of the 2. And then we could break here as well. If you didn't break here, it wouldn't make a difference, because what you've done here is set the guess min to equal the max. And then it'll then come out of here, hit here, it'll go back up to the while loop, and then it's going to do a check, is while the guess min isn't equal to max. Well, we just set the guess min to the max, so that means it's going to come out of this while loop anyway. So we could just leave this statement like that. But say you were to do something else after this if statement. Say you were to then do some logic here, such as guess min equals max times 2. I mean, this is not what you would do, but you could have logic here, which would then mean your presumption that just because guess min is max right now, you haven't actually got to the next check of the while loop. There's still code that could be written here. So it's a good idea to break out of this loop because you know you've got the answer. So even though the while loop would evaluate to false here and then break, there's no presumption that we might in future decide to add some code here, which then effectively breaks this. So we're going to escape here because we know the answer at this point. So now we should have the no version. So let's go and check that. Press F5. Press enter. Let's answer yes. We're now down to the 0, 1. We answer yes, it's 0 or 1. Is your number 0? We're going to say no this time, which means the answer should be 1. And there we've correctly figured out the number's 1. So far our code now is quite happy. While the user's answering yes, we're halving the numbers all the time. When we get to the final 2, we also then correctly answer yes or no. So all that's left to complete this program is to figure out when the user answers no. So let's do that. So here's where they answer yes to the main question of the range, and here's where they answer no. So let's put a comment on here. And we will do the number is greater than guess max and less than or equal to max. So now we need to readjust our range for the next time we come into this guess statement. So we need to readjust guess, min and max. So we want our guess min, sorry, our guess, we want our guess min to now be 1 above the last guess max, because they confirm that their maximum guess, which let's say from the start was 0 and 50, they're saying that their number is not between 0 and 50, which means now the new minimum must be 51. So the guess minimum equals the guess maximum plus 1. And now we need to deal with the new maximum. So we want to get, again, the difference between the two numbers. So let's just keep this in a variable to make it read easier. So now we want to guess the bottom half of the new range, which is what we do in both cases. And we want the, let's call it remaining difference. And that's going to be, again, this is all we did here. It's just slightly different because we're now dealing with the maximum as opposed the guess max, because they've said no to the guess max, so now we've got to resort to the known maximum, which is the max value. So that is the true maximum value minus the guess maximum value. So in the first guess we said 0 to 50 in the guess max, and the known possible maximum was 100, so it's 100 minus guess max. So the difference would be 50 in this case. And we're starting at 51, and now we want to know half of that difference because we're always guessing halfway down. So we want to do the guess max is the remaining difference divided by 2. Now we've got to think about something here, because we're stepping upwards, and because we've done this plus 1, we're going to end up with an issue here. And you might not realise it right now, but let's see if we can get this to happen. So let's at first see how this goes. We need a comment on here, which is really set the guess max to halfway between the guess min and max. Let's do the variable name. Right, so let's run this code and let's see what happens when we start answering no. So is it between 0 and 50? We're going to answer no. It's going to come into here. The guess max was 50, so it's going to add 1 to it, which means the guess min's 51. So the next question he should say is your number between 51 and. Then we're going to take the max of 100 minus 50, which is 50. We're going to now set the guess max to the remaining difference, which is 50. divided by 2 is 25. So that's wrong already. Let's just stop there. We need to add this difference to the max. Because the max is 50, the remaining difference divided by 2 is 25. We want to add that because the guess min is now starting at 51. So we just want to put a plus here. We want to do the guess max is plus this much difference. So let's answer no to that. So we should get between 51 and that'll be 50 plus 25. So it should be between 51 and 75, which is correct. So instead of asking between 0 and 25, which is halfway between the lower half, we know 0 and 50 is not right. We want to ask between 0 and 100, and we want the lower half of those two, which is between 51 and 75, which we've successfully got. Okay, that's good. So if we answer no again, it should come back into the same loop. The guess max right now is 75. So plus 1 is 76. So we jump 1 above because we know it's not there. The remaining difference, the max is still 100. Minus the guess max, which was 75, is 25. Divided by 2 is 13 because it's going to round up. So you're going to get 13 plus 75. So let's answer now. And there we do, we get 12. 75 plus 12, so it's actually rounded down. So let's just keep answering no, and let's see if I can get the issue that I'm expecting to see. Issue. Oh, we're not actually hitting that issue. So the issue I'm trying to find is if this number, if the difference is 3, then you do 3 divided by 2. Because these are whole numbers as integers, what's going to happen is 3 divided by 2 is, I believe, going to give you 1. So let's just do a quick test. Let's just simply do console.writeLine. And then let's do 3 divided by 2. Let's just see what that gives. So you see 1. So the issue you've got there, where are we? Here. So if you've got a minimum number, I'm trying to think how we can get this. I know it will happen. You've got a maximum. In fact, let's try and get to... Let's just try a few numbers and see if we can get it to happen. No, yes, no, no. Ah, there we go, perfect. So you can see here, we've got an issue. Issue number between 73 and 73, so something's gone wrong here. So we've answered issue number between 70 and 72. We've answered no. Now bear in mind we've answered yes here. So with the numbers between 51 and 75. Then we've just answered no, no, no. So the maximum is 75. The number could be 75. As we've come down, the minimum's increased. So at this point, we've confirmed our number is not less than 72. So our number is either 73, 74 or 75. But then we've gone ahead and asked, is the number 73 or 73? But the number could be 73, 4 or 5. And what happened was, in fact, we can stop and step through this. So we know if we answer no, yes, and then consecutive no's. And then we'll put a breakpoint in. And let's see what happens. So we went no, yes, no, no. Right, and this is where the issue happened. So what we're going to do is we're going to click in this grey area to put a breakpoint. So we can actually step through the code and see what happens and see what's gone wrong. So let's press no. And this should then ask us, is it between 73 and 74? Because it's either 73, 4 or 5. So let's see what's going on. You've got guess max, which is currently 72. If we step backwards, you can see there's the current guess max. So we were going to add 1 to that to set the min, which is correct, which should be 73. So press F10 to jump to the next line. Guess min is 73. Good, so all's going well, all's correct so far. The remaining difference is the max, which we know is 75, which it could be, minus the guess, gives us 3, which is correct. So we know the difference is 3, so all's good so far. We've got the min, 73, we've got the max difference of 3. So it's 73, 4 or 5. Now, the guess max is 72. We want to add 2 here, because the difference is 3 divided by 2. We know from before this is going to give us 1, which means the guess max is effectively going to be the same as the guess min, which is wrong. So the only circumstance this would happen in is if the remaining difference is exactly 3, because we're always dividing by 2. So every time we do this loop, we are always dividing by 2. So regardless of the number, if it was 5 and you're going to divide by 2, let's do that. So let's just do console.writeLine 5 divided by 2. And you see you've got 2. So it's not a problem here because you've not hit a single, you're not down to a 1, you've still got a difference, and effectively if the answer's no to that difference, you're going to add 1 to that. You're always going to cover your bases, you're always going to guess above or below, so it doesn't become an issue until you get down to a number with 3. And then you're going to get the issue that you've effectively lost a number in this calculation. You've done whole numbers divided by 2, which is trying to give you a fractal number. It's trying to give you 1.5. And in this case, we want to always what's called ceiling that number. We don't want to floor the number. We don't want it to be the lower of the possibilities. So if you've got 1.5, you've got 2 possibilities. It can be 1 or it can be 2. Now, by default, a whole number is going to round down, so it's going to go down to 1 instead of up to 2. So what we want to do is force this to the maximum of, if the number's 1.1, we want it to be 2. Basically anything above 0.0 we want to go upwards. So if it's even a fraction over of a certain number, we want it to jump to the higher of the 2, and that will fix this issue. So to do that, we can use the math library. And that is capital M, it's math and dot ceiling, and this returns the smallest integral value that is greater than or equal to the specified decimal number. So it's basically what I was explaining, and what that means is the smallest whole number that's greater than or equal to the specified decimal number. So as I was saying, if you did 0.000001, this would return 2. If you do 0, it's going to return 1. Basically, anything above that whole number is going to jump to the next whole number. So 0.1 would jump to 1. 0.5 would jump to 1. 0.7 would jump to 1. 1.01 would jump to 2. On the opposite side of that, you've got math.floor. And this returns the largest integer, less than or equal to the specified decimal number. So it's effectively the lower number. So if we did math.floor 1.99, we'd get 1. So as we said, we want to return the ceiling, the maximum number out of the 2. So 1.5 will get rounded up to 2. So it's expecting the number that you want to round up. So we just pass in the calculation. And there's one more step here, which if you're dividing an integer, which this is, by 2, which is another integer, you're dividing whole number by whole number. So this is already going to pre-calculate down to 1 and then end up passing exactly 1 into this function. So it still wouldn't work. The trick to get this to actually calculate as a floating point number is that as long as one of these two numbers is a floating point number, the calculation would work. So simply put a lowercase f after the 2. And this will turn the 2 into a floating point number. And now, this is now going to return number 2. But the issue here is now, cannot implicitly convert type double to int. So, this guess max, we defined as an integer. This math.ceiling is actually trying to return a double. So it's trying to return a floating point number. So what we need to do is change that double that this is now returning. So this double is trying to set this guess max to a double, and you can't do that because this is a whole number. So you need to cast this value, and all it means is convert this value of a floating point number back into a whole number, which we're fine because this is going to return a whole number anyway. This is going to return 2. So it's going to return 2.0, which is a floating point, but 2's fine. When we cast to an integer, it's going to effectively cast to the number 2. So to do a cast, you just put parentheses before the thing that you want to cast, in this case the return value from this function, and put the type that you want to cast to. So you type int. So this being before this has effectively changed the return type of this function from double cast into an integer. So all this function has done, which we should make a comment about, and you can put capital note colon math.ceiling will round up the remaining difference to 2 if the difference is 3. And this is a fix for effectively those numbers where the difference is exactly 3. So that should be it. I believe this whole program should now work. So let's first do this check again, which, if I remember rightly, was no, yes, and then just no. Yeah, there we go. So if we answer no to this, our number should be between 73, 4, or 5. And before it was asking, is it between 73 and 73? Now it should ask if it's between 73 and the rounded up version, which should be 74. So let's see if that works. And there we go. So now we have, is your number between 73 and 4? Because right now it could be 73, 4, or 5. So if we answer no to this, we know the only possible number is 75. So if we try and follow what our code would do, we answer no here, we'll get into this part. So in fact, let's debug and step through. So let's click a debug there, and let's answer no to this, because we now expect our program to realize that the number can only be 75. So we come into here, the current guess max was 74, which it was. The new guess min is going to be 1 up on that. So the guess min now, the next minimum is 75, because we've said it can't be below that, so it's got to be 75 minimum. We get the remaining difference, which is 75 minus 74 as 1, and the guess max 74 plus, and then effectively 1 divided by 2, and then it's going to round it up, so it's going to be half rounded up to 1. So the guess max is going to become 75. So the min and the max are the same now, so there's an indication that we're on the right track. But do we detect that? So now we say, if the guess min, 75, plus 1 equals 75. So no, we don't detect that. So this check here was if we only have 2 numbers left. So actually that was fine. But now we'll get into the while loop. We're saying guess min, while the min isn't equal to the max. Well, it is right now. We've ascertained that the minimum is now the exact maximum. So this while loop is now going to break. There you go. It's no longer true. So this whole loop has now effectively ended, which is exactly what we expected because we've guessed the number right. So now we've come out and we're going to output the fact that we know the number's 75, and the guess is 6. And there we have it. So on a quick check, this looks like it's all working. And I know this is a lot of logic to understand, and I don't expect you to understand so much about the actual logic behind this equation. This was simply a perfect test to go through a lot of ifs, else's, calculations, putting brackets. And I'll touch a little bit on these brackets that I've been putting in and not explaining too much. So if we do, let's use our console.writeline to just see the output. You can do math equations. So you can do, as we've been doing, things like max divided by 2. Guess max is guess max minus min divided by 2. There's a lot going on here. And in maths you need a an order of how you do things, what you do first. So for example, if I did 2 plus 2 times 3, now let's do times 4. So there's multiple ways you could interpret this. You could say, well, 2 plus 2 is 4, times 4 is 16, okay? You could also do 2 plus 2 times 4. Well, 2 times 4 is 8, plus 2 is 10. So we've got two possible outcomes here. We've got 10 or 16. So let's run and see what happens. So it's 10. So what that means is, and what you'll find out, is there's an order of priority to these operands. So the plus and the minus are the low priority. The times and the divide are the high priority. So by default, when C# tries to calculate this expression, what it will do first is calculate the timeses and the divisions. So it will do 2 times 4 first is 8, and then that'll convert down to 2 plus 8. And then it'll do 2 plus 8, which is 10. So say we actually meant to do 2 plus 2 is 4, then times 4 is 16. The way you do that is you put parentheses around the section you want to calculate first. So now C# will, as it's going through this equation and working it out, if it hits parentheses, it'll first step inside of them. Similar to if you think of it like a function's curly brackets, it's going to go inside and do something, then come out. So it's going to go inside this function, it's going to do 2 plus 2, which equals 4. It's going to come out of that and replace it with the result, which is then going to be 4 times 4. So if we run this now with parentheses between the 2 and the 2, we're now going to get 16. So what we're doing when we put brackets here, it's because if we didn't have the brackets here, guess min and guess max, now you can see what's going to happen. This division is going to take power, and it's going to do guess min divided by 2. And it's going to replace that with the value. And then it's going to do guess max minus half of guess min, which is not what we expected. We were trying to say half of the guess max minus the guess min. So we put in parentheses the thing to equate first. So it will first find the difference here. Then it will divide by 2. So then our equation's order is correct. Now, you can see down here, this part is actually the exact same logic as this part, just using different variables. And you see I've done the calculation here, max minus guess max. It replaces this part here. But because I've done it first as a variable, then I've put this variable into a calculation directly, divide by 2 like here. There's no need for the parentheses because I've already done the equation first and then added it later. So when you're doing any kind of calculation and you want to keep them in a single line such as this, you need to be aware of what you're thinking is going to happen in terms of what gets minused and plussed first and what gets timesed. Is if there's a minus or a plus, it will always get done after the division or the times. So you look for the times and the divisions, and you take the first thing to the left, the first thing to the right, and that will be calculated first and reduced. So there's your parentheses use. So back to this program, as we say, this is a lot in one program. This is a fairly long tutorial, and we've gone straight into some complicated things, and hopefully to get you up to speed quick and for you to see something actually work in a real program that does some actual calculation instead of just outputting hello world. So you can go over this tutorial, you can just pause the video and go through this code as I've scrolled through, and you can read it, you can mess with it, you can try and break it, and hopefully understand it. So let's just run it once more and do a few quick checks. So we press enter. I'm going to think of, say, the number 77. So is your number between 0 and 50? No. 75? No. Now, yes, my number's 77, so it's in between those two, so yes. 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 Getting closer. Yes. Yes, it is. Is your number 76? No. Your number 77, and there we go. It's guessed it in the maximum possible guesses, which is 8, but that's still guessed a number between 0 and 100 within 8 guesses. So So that's quite cool. So let's do that once more. I'll go with, let's say 0. So is your number between 0 and 50? Yes, 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 yes. Yes, yes. And then yes it is. So 8 guesses again. Let's pick the number 24. Yes, yes, no, 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 yes, no. 24. Good. So this is looking like it's working well. So I'm not sure whether this has got any bugs or issues. Like I say, I've just made this on the spot for this tutorial. Feel free to see if you can find any issues with it or improvement suggestions. Leave them in the comments. I'll be happy to improve this. And I think the next tutorial we will reuse this exact program. And what we're going to do is we're going to improve on it even further. So right now you can see this is not that large. It's only 93 lines of code. But already when you open it up and you generally glance through, it's just all code. It's just all writing, and even though we've got comments, it's one big lump. It's a single function. It's just got everything in. So we're going to take the program further, and we're going to go into creating functions and doing some regions to tidy code up, and we're just going to really get this to a level I'd be happy with as a professional software developer. We're going to go that next step and tidy this program up. So that's what we'll do next.